if the question asks for the enthalpy of solution, then the question is asking for delta H reaction. And to find it, you have a fraction, negative Q over N reaction. Now, Q is just MC delta T. N reaction means the mole of the limiting reactant divided by the coefficient. That's if we have a limiting reactant. Like if we have two reactants, one of them is going to be limiting. If we have a single reactant, that's going to be the limiting one.
Okay.
Okay. So let's look at this question, right? They're asking for the enthalpy of solution. And so the first thing you want to do is you want to find the Q. Q is equal to MC delta T. Okay. Now, the question is, what mass do you use? Because here it says that the solution has a specific heat capacity of 4.18. The solution. What's a solution? It's the solute and the solvent. No, yeah, the solute or the solute, you call it, and the solvent. Okay? That means you actually have to add their masses together. Now, if they just said specific heat of water is 4.18, you would just use the mass of the water.
Okay.
But if they say the specific heat capacity of the solution, that means you have to have the solute and the solvent. Now, we are not given the mass of the water. We're just given the volume. But guess what? They also gave us density. So density is equal to mass over volume. So 1.00 is equal to the mass, which we're looking for the water. The volume being 500. So mass is equal to 500 grams. Grams, yeah. Yeah, because density is in gram per ml.
Yeah.
Okay, so now that's the mass of the water, but again, we want the mass of the solution. So you must add the mass of the CaCl2 and the mass of the water together. Times C, which is 4.18, that's a specific heat capacity.
And delta T, which is 27 minus 23.50.
Yeah, so 27.00 minus 23.50. And now we're going to go ahead and do the math. So 510 times 4.18 times 27 minus 23.5. Now, I got a big number, 7,461.3. But don't forget, we have to, keep in mind the significant figures have to be correct. And we have to have 3 significant figures maximum.
Okay.
So right now my number has 5. So I'm going to go ahead and I'm going to just make that into a 0. Because the 0 on the right of a whole number does not count in terms of sig figs, joules. Okay, now. How about the N reaction, which is the mole of the limiting reactant? We only have a single reactant, which is the CaCl2.
So try to find the most from 10 grams of CaCl2.
Yeah. Divide by the molar mass, which we have to find. So Ca is 40 and Cl is 35.45, but there is 2 of it. So 35.45 times 2. So now I got 0.090 17 mole. And now the last step is to do delta H reaction is equal to negative Q divided by the N reaction, which is 0.09017. So 7460 divided by 0.09017. And I got myself again a big number, which is negative 8273.6, but I only have, look, here I have 3 sig figs and here I have 4. You should always go with the least. So that means I have, exactly. So I'm going to make it negative 8.27 times. Now look, I have here 1, 2, 3, 4, all on the right of the decimal point. That means I must write 10 to the power of 4 joules.
Do I also have to write in scientific notation, or doesn't really matter?
You could just write or negative 827 and now make the 3 and the 2
cancel out.
not cancel out, just make them into a 0, because 0 and a whole number on the right doesn't count.
Okay.
Like that. Okay. So we know that a white precipitate forms. That means that something insoluble is going to form. And they're like, write the net ionic equation for the reaction. Well, look, you will take the AgNO3, take it with the KCl, and do what we call a double displacement reaction, where the first reacts with the last, and the middle ones react with each other. Make sense?
Yeah.
So now we're going to have AgCl with KNO3. Now some people don't know if they should write NO3K or KNO3, or if they should write ClAg or AgCl. You should always put the positive ion first. So right now, if I write ClAg, I'm going to have negative ion first. Negative first, that's not allowed. Always have the positive ion first. Okay. So that means you actually have to know the charges or the oxidation states. Now, which one of these is the white precipitate?
I feel like it is the AgCl.
Yeah. You should know your solubility rules. And they say that if you have alkali metal, or if you have a nitrate, or if you have ammonium, all of these are going to be soluble, which means not a precipitate. And here we have alkali metal or nitrate. You just have to have one of them. Here we actually have both. So it's definitely not precipitate.
Okay.
Okay, now we took care of the net ion equation, and here actually we have two reactants, right? And we have to know which one of them is going to be the limiting reactant, because that's going to affect everything when it comes to finding delta H. So, you should first find the mole of each reactant. Do you know how to do that? You multiply the molarity by the volume.
Yep.
So 0.500 times. It's your job right now to turn that ml into L.
Liters.
So divide that by 1,000 and you get this much. Let's see how much that is in the calculator. And here I got myself a 0.015 mole. Actually, I should have the right number of sig figs. I must have one more zero. Even though the calculator isn't showing up one more zero, it's your job to put that one more zero. Because you must have how many sig figs? 3. They both have 3. That means you must end up with a 3. Now that's the mole of the AgNO3. Let's now find the mole of the other one, which is the same, right? The same exact numbers.
Yeah.
So they're both going to be 0.0150 mole. Now the main question is, which one of them is the actual limiting reactant? Now, do you know how to find limiting reactants? You take the mole and you divide by the coefficient.
And they both have the same coefficient.
So they're both limiting.
Yeah.
So that means when you do the math, you can use any number of the two because they're the same. Now, what's our second job? To find the Q. Q is equal to MC delta T.
But we don't have the mass.
We don't have the mass, right? But here it says that the density is 1, right? Of the solution.
Oh, and you can find the density by moles and...
Yeah, because we know the volume. We know the volume.
Mm-hmm.
And the volume is essentially mass when density is equal to 1. So we're going to say density is equal to mass over volume. Density is equal to 1. And the mass is 30 for one of them, let's say. The mass is unknown, but the volume is 30.
Mm-hmm.
Cross multiply. And you get 30 grams That's the mass of one of them, and you have two of them with the same exact volume. So add it up, right? So you're gonna have 30 plus 30. Make sense why I did it twice? Because we have two.
What are you calculating for? Determine the... But it doesn't say find the...
Yeah, well, to find delta H, I must find the Q first.
You know what I'm saying? Of the solution, is it for AgNO3 or KCl?
Solution means both.
Okay, but it does not say both.
Well, solution means both. Like you have to know in chemistry language, solution means both.
If I'm asking, it doesn't say determine the delta H of the solution. It's just determines the...
Well, do you know how I know? Because they gave me the specific heat capacity of the solution.
Oh, it didn't say specific heat capacity of AJ or...
Exactly. So that means you have to put both of them.
Okay.
Now I know that this is going to be 30 grams. And that's going to be also 30 grams. So put them together. That's going to be 30 plus 30 times C, which is
4.18.
exactly. And delta T, which is the final T,
Which is 26.80 minus 23.
exactly. How much do we get? Let's use the calculator. So 60 times 4.18 times 26.80 minus 23.00. And I got myself a 953.04. But how many sig figs should I have?
3.
I don't ignore the last two. It's just a point. So joules. Now, I'm going to find delta H.
Wait, Mr. Just 1 0 on the right side count as a sig fig? Just 1 0. Like, say you have 95.0. Is that 3 sig figs?
That is 3 sig figs.
Okay.
But if you have 950...
Wait, Mr. If you have 0 to the left, does that count as sig figs or not?
No, like if you have 0.80, that's only 2 sig figs.
Okay.
Look, if you want to make the 950 count as 3 sig figs, you should add a period. And now it's 3 sig figs. That's going to make the 0 count.
Okay. So if you don't add a 0, it will not count.
Yeah.
It's so confusing.
It is.
Oh.
Okay. Like how many sig figs do we have here?
We have 3.
3. Because those zeros don't count. But the 0 on the right and the decimal number counts.
Okay.
Okay. Anyway, so now delta H is equal to negative Q over N reaction. So negative Q is negative 953. And reaction is just the mole of the limiting reactant, which we said they're both limiting.
So 0.015.
You take it and you divide by the coefficient, which is how much?
1.
A 1. So don't do that. Okay? If there is like a 2, you divide by 2.
And it was a 2 and you multiply this by 2 as well, right?
No. You just divide the mole. Look, mole limit. Look, what does N reaction mean?
Mole of the reaction.
It means mole of the limiting reactant divided by its own coefficient.
Oh, so if you had a 2 over here, you divide this by 2.
Yeah, so if we have here a 2, you gotta divide this by the 2, okay, for example. Alright. So now you're gonna get 0.0150. And now we should do the math. So 953 divided by 0.0150. Now I got myself a negative 63,533.3. How many sig figs should I have?
3.
3. So I'm going to turn those into zeros, right? 2 zeros. No? Okay, look, let's go back. Look, I'm going to make it into negative 635. But those 3's become what?
Zeros.
Exactly, because zeros don't count for sig figs in a whole number.
Okay.
So I'm just fooling the system essentially. And now just replace that here. So don't give them 2 answers. Just give them the final answer that you got, okay, with the right figs. But the question, joule per mole reaction. But the question says find delta H in kJ mole. kJ means I have to convert my J into kJ, right?
Yes.
I must divide by 1000. So negative 63.533. 0.5 kJ per mole. Just divide the calculator and you get this number.